Alright, so let's look at these word problems. We're going to draw our pictures. And do our 4-step plan and see what we can come up with. So you can do them with me or on your own and then check it as I go through it. It's your choice. I'm going to have to use my own calculator up here rather than yours, so some things might look different. So I'm out of class calculators. Alright, so as we look at this, let's draw our picture. It says a tree 40 feet high casts a shadow 58 feet long. So here's my tree. It's 40 feet high from here to here. And here's its shadow. And this shadow is 58 feet long. Find the measure of the angle of elevation of the sun. Right? Where's the sun? If the shadow's going this way. Okay, it's in the sky. I like that one. Is the sun over here? Is it over here? If the shadow's this way, the sun should be somewhere back over here, right? Okay. So the angle of elevation, let's assume at this end point of the shadow, the sun's going to be somewhere up in this direction, won't it? So won't my angle of elevation be there? And it's asking to find that angle of elevation, so I'm going to let that be x degrees. It's harder to find, for you guys, it's harder to find the angle than it is a side length. So this is where we're going to use the inverse. If we're trying to find the angle, we're going to use the inverse. That means we're either going backwards in our table or we're doing the inverse on our calculator. So let's set up our equation. If this is my angle of reference, this is the leg opposite, leg adjacent, or the hypotenuse. And what's this one? Adjacent. And so I've got OA, SOCA, or TOA? TOA, right? So that means I am choosing tangent. Do I know my degrees? X degrees, right? So I put X degrees equals. Then your ratio goes over here. Opposite over adjacent. My opposite is 40. My adjacent is 58. You could reduce that if you wanted to, but why? We're using a calculator. So, since we're using the calculator, remember that you have to physically write. If you don't write this, you're going to lose points. That you are doing the inverse tangent of 40 over 58, and that's what x is equal to. So x is equal to the inverse tangent of 40 over 58, and then that's what you're going to put in your calculator. But what do you have to remember to do before you ever use your calculator? We have to check the mode. It's vitally important every time you do these problems, go and check your mode. So I'm going to go into my mode, and is my mode appropriate? What should my mode be? We're working in degrees. I want my mode to be degrees. So most of your calculators probably are showing radians. So scroll over, highlight degree, and you have to press enter so that radians is no longer highlighted. So now our calculator's in the proper mode. If you have a scientific calculator at home, or remember, if you have a smartphone like an iPhone, I don't know about the Droid phones, but the iPhone, the regular calculator in an iPhone, if you turn it sideways, doesn't it turn into a scientific calculator? So you can use that, and on scientific calculators, mode doesn't matter. So then get out of mode by pressing second quit, which is second mode. And now we're ready to put this into the calculator. If I want to get to inverse tangent, what do I press? Second, and then tangent, and it has to say tan to the negative 1. And then put in the entire fraction and end the parentheses. So 40 divided by 58 and those parentheses. So we're going to round to the nearest, since it's a degree, what does the direction say to round to? The nearest degree. Now this one's actually 34 point rounds to 6, doesn't it? It's almost directly in the middle, but it is closer. 34.6 is closer to 34 or 35. It's closer to 35. So x is equal to 35 approximately, because we just rounded, degrees. Therefore, the angle of elevation, I'm running out of room, of the sun is about 35 degrees. Now, if you're using your table of values, I want you to start to do this with your table of values, but instead of this, what would you write in here? Your 4-digit decimal. I'm going to know whether you're using your calculator or your table of values by how you show your work. So I want everybody to start writing the inverse tangent. But if you're using your calculator, you can just put that in as is. If you're using your chart, you need to find the 4-digit decimal. Yes? If I don't know my degree measure, if that's where my x is for my degrees, I will always do the inverse. If my x is over here in my ratio, then I'm using the proportion method to solve. Does that make sense? There's only 2 different ways we can solve, the inverse or using that proportion. And so 40 divided by 58, and this is the only time I'll do this today. So 40 divided by 58 is 6897, right? So I would go underneath tangent, and I would look for 6897. So my 6's are at the bottom under the tangent column. 64, 67, they're getting bigger as we go down. So it's somewhere in between here. It's somewhere between 34 and 35. If you're using your chart, I will still allow you to say 34.5. So if you're using your chart, don't try to get to the closest one, because what if you make a mistake and go in the wrong direction? Then I'm going to have to mark you off. But if you do 34.5, you and I are both happy, right? If you're using your calculator is going to give you the exact. Questions on that? Okay, so let's look at 3. So 3, well, they love ladders. A ladder is leaning against a house. So here's my house. Oh, I got a lovely window there, right? Here's my ladder. It makes an angle of 60 degrees with the ground. That was important. It makes an angle of 60 degrees. The ladder, makes an angle of 60 degrees with the ground. So here's my ladder, and here's the ground. Do you see the angle? They're describing it to you. Is that an angle of elevation or an angle of depression? Elevation. The foot of the ladder is 7 feet from the foundation of the house. Put your finger on the foot of the ladder and trace it to the foundation of the house. Foundation is at the bottom of the house. So foot of the ladder, foundation of the house. Isn't this the length that they're talking about? So they're saying that it is 7 feet right here. How long is the ladder? So your x has to be placed where the ladder would be. So this should be a right angle of the triangle there. So we're trying to find the hypotenuse of that triangle. So if this is my angle of reference here, what is the 7 feet? Like opposite, like adjacent, or hypotenuse? Adjacent. And this, x, hypotenuse. So I have AH. Is that so, ka, or toa? Ka. So we're looking at cosine. Do I know my degrees? 60. And then my ratio is A over H. So adjacent is 7. My H is X. So this is the harder proportion. And I know I'm doing a proportion because my X is in the ratio. So I'm going to put this over 1. And we're going to cross multiply and solve. I get X, and I still need to see this. Some of you are skipping steps. Please don't skip your steps. Because if you do something wrong, I will give you very little partial credit, which is what happened to some of you on your quiz. Then, to solve for x, I'm dividing by cosine of 60 degrees. And so x is approximately equal to, this is what I'm putting into my calculator, 7 divided by cosine of 60 degrees. If you're using your chart, you will replace that cosine of 60 degrees with its 4-digit decimal and then do the division on your calculator. But we're going to use our calculator. So I've got 7 divided by regular cosine, not an inverse, of 60, and end your parentheses. We get a nice little number, 14. So therefore, it's not even approximate, isn't it exactly equal? What you will learn is the cosine of 60 degrees is 1/2, but you will learn that next year, how to know that for sure. Isn't 60 a special right triangle? Couldn't we have used special right triangle knowledge here? We could have done our 30, 60, 90 here too, right? Either way would have been acceptable. So therefore, x is the length of the ladder, so therefore the length of the ladder is 14 feet. And then the balloon. A balloon on a 40-foot string makes an angle of 50 degrees with the ground, because we know all balloons are attached to the ground. So here's my balloon. It's on a string, somehow attached to the ground. It's on a 40-foot string, so this is 40 feet. How do I know that that string's at a diagonal? If you're holding a balloon, how often does the balloon stay directly over your head? Not very often. Especially if it's on a 40-foot string, isn't there going to be some sort of breeze up there that typically is going to carry it away from you? And it makes an angle of 50 degrees with the ground. The string, makes an angle of 50 degrees with the ground. So this right here is 50 degrees. How high above the ground is the balloon if the hand, oh, now we have a hand of a person holding it. Oh, I love that. Here's my person holding it. Thank you. So we have to adjust a few things, don't we? So the question is how high. There's our x. But it says if the person is holding it 6 feet above the ground. Don't we have to make an adjustment? We're assuming now that this angle we're going to have to make the assumption that this is going to be x minus 6 here, isn't it? Where did I come up with that? I don't like how they said that the balloon makes an angle of 50 degrees with the ground, because then technically isn't the person like over here holding the balloon right there, how they described it? And I'm pretty sure that's not what they meant. I'm pretty sure what they meant was that the 40-foot string makes an angle of 50 degrees with that person's hand. But if you think about it, if he's holding it up here 6 feet off the ground, then this angle, well, it should still be the same, shouldn't it? Wouldn't we have similar triangles here? If he's sitting here holding it 6 feet off the ground, if this is 6 feet from here to here, aren't these similar triangles? If that's 50 degrees, won't that still be 50 degrees? Do you see what I'm saying? Here it is, 40-foot string all the way to the ground. Is it really on the ground? Isn't it looking like this? Here's the string, right? He's really holding it up here. Here's the balloon. This is the 40 feet. This is now your line of sight. But the ground is all the way down here. This is 6 feet from here to here. If the string makes an angle with the ground all the way down here of 50 degrees, aren't these parallel? Right? So if that's 50 degrees, this is 50 degrees because they're corresponding angles. But the 40 feet is from his hand to the balloon. We're going to end up finding x. But does x represent the height the balloon is off the ground? So I guess it's not x minus 6, it's x plus 6, isn't this 6? So you have a choice. You could either make this x plus 6 or just make it x, and then when you're done, add the 6 to it. What would you rather do? I'd rather add the 6 to it at the end. It makes it a whole lot less complicated. So if this is my angle of reference, what is this? Here's my right angle. Opposite. What's this? Hypotenuse. So I have OH, SOHCA, or TOA. So that implies we're using sine. Do I know my degrees? Yes or no? 50 degrees equals, and then opposite is x, hypotenuse is 40. So I know my degrees, so this is the proportion method of solving. I'm not going to use the inverse sign. I'm going to cross multiply and solve. So 1 times x is x equals 40 times the sine of 50 degrees. If you're using your chart, you will replace this with the 4-digit decimal of 50 degrees so that I know you're using your chart. If you're using your calculator, because one method will give you a different answer than the other. They'll be close, but they'll be slightly off from each other. This method is going to give you the most accurate answer if you're using your calculator. Using your chart approximates it more than your calculator. So we're going to take 40 and multiply it by sine of 50 and end your parentheses. Does the answer for x seem reasonable? 30 point what? 64. And isn't that feet? So that's my x. Is that a reasonable x? Don't we expect it to be less than 40 because the hypotenuse is the biggest? Is that our answer? The question, they want to know how high the balloon is off the ground. So don't we have to add 6 feet to that? 36.64 feet. Therefore, the balloon is about 36.64 feet off the ground. Or the height of the balloon is. I guess that'd be a lot less words. Any questions on that? All right, so I'm going to do a bunch of homework problems with you, or as many as